The next talk is by Caroline Morton. She is a medical doctor and epidemiologist, which is a hard word for me to say, but she's also the co-author of the Async Rust book by O'Reilly, and she's created the Women in Rust group. And at the end of your talk, there will be a way that you can contact her about that if you want to get involved. And her talk is about how we can use Rust, like sort of from a different perspective, how we can use memory-safe and performant programming languages to improve scientific outcomes. Take it away, Caroline.
Well, thank you very much for having me here. So I can't actually stray too far from my laptop because I've got one of those annoying MacBooks that's only got 2 ports, so I can't plug in the clicker. So I'm going to be here. It means I can't see you. So my name is Caroline Morton. So who am I? So I've already been introduced, but I work now as a software developer. In Rust, I do consulting, and I also run this company called Clinical Metrics, which is a simulation company we make. It's like an emergency room simulation. I previously worked as an epidemiologist and as a doctor. I've done lots of epi papers, epidemiology papers, and kind of got into programming through that way. So from like a statistical programming perspective into programming. And then I was lucky enough to co-author this Async Rust book. And as mentioned, I've set up with someone else, Women in Rust, and there'll be a way to contact me at the end if you want to get involved. Okay, so this talk is going to require a little bit of explanation about what the problem is I'm trying to solve. So bear with me, there's a lengthy introduction, and that is very much on purpose because it is something which is kind of complicated. So we'll go through the problem, we'll talk about the tool, what my plans are for the future, and please implore you to get involved, and then some of the key lessons that I learned for this specific journey, trying to implement something for kind of scientists, basically. Okay, so we're going to start with this question, which is, what is a coded event? Okay, so the way that I always explain what a coded event is to think about you as a patient. Okay, you're a patient, you've got a cough, you feel rubbish, you go to your doctor, and they examine you, they, do your temperature, they think you've got a chest infection, you've got a pneumonia, give you some antibiotics, and away you go. Okay, so you may see your doctor writing notes furiously on the computer while you're doing that. At least that's what patients always complain about, is that their doctor is writing on the computer. And you might assume that that is just free text that is going into the computer. But actually what happens is, as they type, things are being popped out and said, you've started typing pneumonia, do you mean pneumonia? And so it's like a pop out. And that, from a doctor's perspective, is really useful because it's like, oh, I don't have to type the whole word. Brilliant. But what it actually is doing on the back end is it is assigning these numerical codes to things that you've written. Okay, and that is a coded event. So you can see on the left-hand side, there is a number, that's a SNOMED code. And in the middle, you've got the term, and sometimes there's a measurement associated with it if it's like a blood pressure. And so we're going to come back to what SNOMED codes are, but that is how your appointment would be essentially coded in the computer. It's slightly confusing because I'm using the word code and coded quite a lot, but if that, I can always clarify that at the end if there's any questions, or actually shout out. So we've got your GP appointment, and we've got your coded events. Now, all of that information then gets put into a table. Imagine a massive table, and we're talking about millions and millions of lines of data, because you can imagine you have your whole life, or you have a family doctor. It gets put into a secure data environment. It goes to a data provider, and then people like me, or people who are doing research, can request to use that data under very specific circumstances that I'm not going to go. It's sort of out of the view of this talk, but we don't have willy-nilly access to your data. It is under specific circumstances. Okay, so what are these codes? So we briefly mentioned SNOMED. So SNOMED represents the world. Okay, there is a astonishing amount of SNOMED options. There's like including everything from different ways that you might get hit by debris falling from an aeroplane to different dog breeds are encapsulated within SNOMED. And yeah, I mean, if you're an epidemiologist, you have such fun games trying to find the most hilarious ones. For example, injury caused by debris from a cargo plane. Very common. The important thing about SNOMED is that it is a tree, okay? So the numbers actually don't correspond to anything like understandable. They're not grouped together, but they are arranged in a tree in terms of like, there's a SNOMED kind of reference guide. So this is a simple example. We would have diabetes, and underneath it, you'd have type 1 and type 2 diabetes, okay? But I lie, because actually there are tens of thousands of different codes. And so this presents a real problem for epidemiologists and researchers who are trying to find all of the people who've got pneumonia, okay? Because there are many different ways that you can represent pneumonia in the data, essentially. So for example, cough, cough is pretty like, you've got a cough, right? There are 43 different ways that you can code a cough, including, helpfully, absence of cough. And this is a terrible website, sorry, NHS Digital, where you can look up different codes. It's very slow, and yeah, there's lots of like repeated data in it. But you can see, if I type in pneumonia, it's not obvious, but it comes up, it matches 2,274 matches. Okay, so what is a code list? So a code list is a way of representing a disease state. So if I'm doing a research study, I want to find all of the people who've got acute confusional state. I need to create a code list, which essentially allows me to find all of the ways that that could have been coded on someone's medical record. And because we're dealing with such huge data, we can't just go and look for it. We have to do it in some, we have to go and find those codes and then run it through the data. Okay, so this brings me on to sort of the fundamental crux of why I've done this project, which is, how is this done? So pretty much any way that you can imagine this has been done. There is no set way of generating, saving, sharing these code lists. When I first rocked up in epidemiology and did my first research study, it was very much like, well, just talk to Sharon up the corridor. She probably has a code list and maybe she'll send it to you, but you have to put her name on the paper, that sort of stuff. So they're like, sometimes they're text files, sometimes they're CSV files, sometimes they are printed at the end of a paper, really helpful. Or on a PDF, okay? Or sometimes they're just absent and you have no idea. And this is really important because we want our data, like the data that we produce, to produce good science that's reproducible. And if we don't know what they've used to generate that data, it's a real problem. Now, there are a couple of notable mentions. So sometimes people do put them on GitHub, and I've been, along with lots of other people, really making a push for people to put it on GitHub. And then there's also this other project, Open Codelists, which, full disclosure, I was involved with when I was at Oxford, where it's that website where you can see them. But it is kind of slow, and it doesn't have everything. So this is a problem that I've been trying to sort of solve in some way for quite a while. And I come to the conclusion that what we need is a standard way of doing this, that you can output something, a CSV file, preferably, with a comma, not any other variation of what you might want to put, like a tab. Again, I look at you, NHS England. And we want it to essentially have like a consistent way that you can generate this data, you can share it. And what I ideally want is that the pipeline for producing that code list is essentially encoded within the code list itself. So it's part of the metadata, because sometimes you get something like, imagine someone's emailed you a code list and you're like, well, it's great, but do I believe it? Why have they done it in this particular way? And often in those cases, you don't necessarily believe that they've got every code that you might need, and so you end up doing it again. So there's just a huge amount of repetition, whereas if we had a pipeline, that would just be removed because you could work out what people have done. The other thing I really wanted was a plug and play. So I really want a way that people can generate code lists in their scripts for their research study. So that's within their research study, but also they can use them in tools like a web API or a website where you could like look at them and share them even. Okay, so I'm starting out doing this project called codelist-tools. That looks like this. It's under it's an open source project, and it is essentially in this organization EHR Tools, which I just started because I was like, while I'm at it, hopefully we'll create some more tools. But codelist-tools, I'm just being optimistic. And so codelist-tools is the first one. Okay, and as I said, this is building on previous experience that I've had, and in particular, this project Open Codelists and this other, my first iteration of trying to solve this, which was a project called TRE Tools when I was at Queen Mary University, which I think I made a bit too complicated because I also tried to do some of the data cleaning aspects of it as well. Okay, so the structure is this. Well, this is the plan anyway. We have a Rust base layer, which is basically small testable packages that do one thing well. Okay, for example, managing the metadata around code lists, or validating that the code list actually contains codes that are real, or a way of editing it or mapping codes. But I don't expect everyone to learn Rust. In fact, most epidemiologists and researchers, they write code every day, all day, but they would never consider themselves software developers. They are statisticians. They would say, no, I just, play around with Python or R, but I'm not someone who writes code. And so we need to make the sort of how they interact with this tool useful for them. And for that, it has to be in a language that they use as part of their normal everyday life. And that is for health research is going to be Python, or it's going to be my nemesis R. See other people have interacted with R. And so the idea is that we have these bindings that allow you to call under the hood. It is calling the Rust implementation of it, but the person using it doesn't need to know about that. Okay, so the first package that we have is just imaginatively called codelists. And this is a central data structure which represents the medical code list. Essentially, it contains the metadata, the codes, the type of code list. Because I've talked about SNOMED. There are several other coding systems as well. ICD-10 is the other sort of really popular one. And this allows you to, I've written some Rust code here, but it allows you to create a code list and then add codes to it. And it does a lot more than that, but my space was limited. Although I didn't realize I was going to have such a big screen. Okay, there you go, a bit bigger. And so this is allowing us to create the contributors. We can work out, we can put in this is where I got the original bit of information for this code list. I manually created it, or I got it from Sharon up the corridor, or whoever. And then really importantly, the purpose and context behind it. So there's been this research paper that has come out, or I guess it isn't really a research paper, more as an opinion piece, where it's saying what information do we want to actually collect about our code lists. And so the middle section, which is dealing with metadata, specifically references the things which have been highlighted in this consensus paper. That's the word I was searching for, consensus paper. And then you can save it. Okay, and then hopefully this has come out. So this is a machine printable version of a code list, which I hope is much more readable, and you can imagine that you could input this in and send it, or like this would also allow you to put it onto a website because it's just JSON, and you can add to it. Okay, so let's come on to the Python bindings. So here we have the Python implementation of this. I opted to use PY03 and for Python specifically, and this is a Python wrapper that essentially is pretty basic. It's like a meta big object essentially, and it allows you to create a code list. Essentially, you're creating it in Rust under the hood, but you don't need to know anything about the Rust implementation. And this is the first time I used PY03, and it was a pretty good experience. It has its own like particular ways of doing things, but once you get the hang of it, it's relatively simple. And the bit on the right is some simple Python code, and this allows us to just import the code list and then add the sort of information that we want to add, like adding a contributor, adding a use, adding some codes, and then we can just use it like any other Python code. Okay. So the second library that we've added is a codelist validator. So when I worked at Oxford, we were doing a lot of the COVID data processing, and you know, when you're dealing with like millions and millions of data, like rows of data, it takes like 8 hours for the analysis to run. So we really need to make sure that any code that represents a disease state, a code list, is valid before it even hits the data, because otherwise it's just a waste of everybody's time. And so this was something that I really was like, oh, we should have this. Unfortunately, we never did, but I think it's something that we should definitely have. And this is quite easy in a sense, because all of the codes have a particular set of rules. So for example, ICD-10 has to be 7 characters or less. The first character has to be a letter. The next 2 characters are always numbers. Then it might be a dot. If it's a dot, there's always a number after it. If it's a cross, it stops, etc., etc. Okay, and so we can just allow for that by using a regular expression. Okay, so in progress. How much time do I have left? Oh, you can just say it. It's 13. 18. Oh, 18. Okay, all right. So what I'm working on at the moment is kind of a big project, which is a code list builder. Again, this is something I've been wanting to do for a while. It's not there yet. I would love some help with it. I have this theory that the amount of time that we're spending writing these code lists basically could be not quite automated, but massively sped up by just doing some sort of keyword search. So I want to build a builder where we can search for a term like diabetes, type 2 diabetes, and it will find all of the codes. It finds similar codes, and it also finds, you can specifically search by a particular code. And the builder is kind of an interesting problem to solve, because it's not as simple as just creating a binary where you've just encapsulated, like essentially put SNOMED and like plonked it into your project, because SNOMED is under license. And so you have to sign the licensing agreement to be able to use it. And so what this project needs is a way that you can use this library and then download SNOMED yourself and say like, okay, here's where it is in my computer, build me the code list builder. Okay, and this is what the data files look like. Well, it's actually considerably more than this, but this is the useful part of SNOMED, where there's concepts, there's descriptions. You need both. And usefully, the description is not with the code for some reason. And then there's also a relationships. One of the files is a relationships file, which tells you how do things associate with each other. So that is coding in that parent-child relationship for like type 2 diabetes and type 2 diabetes with complications, for example. They're massive files, and well, they're not actually massive files, but they're very long in terms of the data that is contained within that. And it's something that needs to go in correctly, but there's also a lot of useless data that we just can chuck out. Okay. So why did I do this? What did I want to achieve from this? I wanted to have a data structure that would allow us to essentially query the builder, as you would a SQL table, and also allow some graphing and querying of that graph. And so I've opted for SurrealDB as a backend. And this allows us lots of interesting and fun possibilities, because we can also use some of the vector search capabilities that they have for finding words which are similar to other words. So yeah, we can talk about that at the end perhaps. So this is how you can load some of the data into Surreal. And so I'm creating the concepts from those text files. That's just via struts. And then I essentially then create a relationship between those different concepts within Surreal. And once we've done that, this is a very small example. I've only put in 10 codes, otherwise it would be massive. We can then look at all of the different relationships, and you can see that there is a graph, and at the top of the tree there'll be, maybe endocrine disorder, and then underneath that there'll be lots of different types of diabetes or whatever. Okay. Here I've got a function which I've written into the database so that you can get child codes. What's really nice about using Surreal is because it is in Rust, it's highly optimized. So it's so quick to get the child codes of, say, diabetes. Okay, upcoming projects. So that's what I'm working on at the moment. So my next thing is a wish list. So I would really love there to be a way that we could interactively adapt and edit the code list. That would be obviously amazing, more so than just editing the metadata. I also would like one day, and hopefully someone in the audience can help me with this, a way of creating an app that allows you as a research organization to point at a particular place on the shared drive and say this is where we keep our code lists, and an app to open up. That, in an ideal situation, this would just be a website. But what I've learned from working in this space for a long time is people don't want that. They don't want to share their code lists openly, certainly not during development. So they might release them at the end when the paper is done, but they don't want it to be open access all the time. Obviously, some people do. And that was one of the big problems that we had when we had open code lists, is it was just open to anyone. And so we need a local solution. Adding in the R API is the next big project. It's kind of tricky because you have to go through C, but now I'm feeling inspired from the previous talk, so maybe I'll be able to do it that way. And then also some documentation website. Cool. So yes, please get involved. It would be great if you have any range of experience. Thank you. So expertise in Rust. I think you probably all are experts in Rust. And then, but particularly if you have expertise in R, that's my nemesis, but we need to do it because that is what people are using. And Python. Even if you've never really written any Rust, come and talk to me, and we can get you involved, even if that's just doing some documentation while you get used to the code base. And it's an open source project. So it's a nice way of being able to show off some skills. Okay. So lessons learned. So I think one of the key things that I learned was I needed to really start from the API first. And I think initially I had a fixed idea of what the Python implementation should be like. So I was thinking, we would basically use classes in Python, and that will be easy because everyone knows what a class is in Python. That's very much not the case. And so I needed to really simplify it. And so I'm very lucky because I still have a foot in the epidemiology space. So I'm able to just talk to people who, I know and engage with users. There's sort of like 3 universities that already said that they'll trial this for us. So we're going to get like a very quick iteration with feedback. Understanding your users is so key. I know that everyone says that, but I think it is really, there's nothing as discouraging as writing a tool which no one uses. And so, I would love to cut R out completely, but we need to do it because people are using, like a lot of epidemiology research is now using R. In the past, people, like when I trained, we used Stata, and I sort of didn't really know very much R, but that's very much changed, which is a good thing because people have moved on to more of an open language rather than one you have to buy a license for. But it is something which is not maybe the easiest language if you come from more of like an object-oriented programming language. It's very functional. And I could have used a C interface to do this, but the code also needs to be really understandable to users because people will be interrogating it, the code base, and being like, oh, is this doing what I think it's doing? And you can have tests, but people like to eyeball the code. And having a decorator saying, this is a method is much easier than having to look at C code. So that was the reason for that. So yeah, as I said, it's been great to engage with some early stage developers within the Women in Rust community, but it is open to everyone. And using the sort of graph and SQL capabilities in one place is really cool. I've previously worked on a project. Well, actually, the company that I run, we have a project. Like our main product, we have all different types of databases for different capabilities. And so it's really nice to just work in one place. And kind of a bit of inspiration, I hope to give to you. A lot of Rust developers do come from science backgrounds. As a show of hands, who did like a science undergraduate degree, master's degree? Yeah, a lot of people. Okay. And I think that what we can do is we can help bridge the software and science. And what I've observed is lots of people are working in the science space and they're doing their own thing and they're doing it really well, but it's a very competitive field. They've got to get funding. They've got to produce papers. They're not necessarily rewarded for implementing a package that everyone else can use. And so people are doing kind of their own thing. And so what I really want to do, because I've got the time and space, this is very much a side quest. I can help build this new way of doing codelist tools. I can also help people who are trying to get started in Rust. And hopefully we can create kind of a better set of tools for epidemiologists and researchers to use. Yeah. And that's it. Thank you.
Very, very nice. Thank you, Caroline.
Very inspiring.
Yeah, go find some questions, I guess. Who's got questions? I see one all the way at the top. There's a challenge.
Hi. My question is, are these things like SNOMED, are they, you said you need a license for them? Does that mean it's a restrictive license?
Sorry.
Sorry, go on.
It is a license that you have to sign up for to say that you're not going to do anything bad with them, basically. I don't know what you could do bad with them. But yeah, so you can, it's used in commercial solutions as well. So obviously the people who hold the electronic health record data, so the data of your GP records and stuff, they are for-profit companies. So they have access to all of these tools. So yeah, but you yourself personally have to sign a license saying, I agree that I will download this.
So it's like Pantone, but for symptoms.
Maybe.
Pantone colours, but for symptoms.
Oh yes, but imagine, I don't know, are there more SNOMED codes than colours? Possibly. Who knows? Maybe all of the colours are within SNOMED. Yeah, I mean, there's so many.
All right. There was a question all the way up there. Or is
Yes,
just throw the box up?
Can I ask?
Sure.
So these codes, I don't know anything about the medical codes. Are they, how universal are they? Are these only like UK? I mean, yeah, are these only UK codes? And in other places there are other standards, or how is it? Are they universal?
Yes, so they're relatively universal. Actually, that's not true. They're not 100% universal. So SNOMED is a international standard, and then each country has their own edition of SNOMED. So the UK version has like some specific things that they don't include that are in international SNOMED, and I think you can also add stuff into your own local edition of it. ICT 10, which is what hospitals in the UK use, is a WHO standard. So that's very much used across the world. But yeah, SNOMED is used in many, many countries. And the code, the names of the codes don't necessarily change between countries. And they shouldn't, in theory, replace any of the names of it, although there was a bit of a whoops about one of the COVID codes, but never mind, a story for another day.
All right, I think the box is almost...
Yeah.
Yes,
all the way in the
there
back
it is.
there.
Oh, wow.
Yeah.
Very nice. So I was curious about the codes. You mentioned the code list builder was something that you were interested in. You'd mentioned that these codes are a tree, so can you imagine it that if for pneumonia you have 12 codes, you'll have one parent code for pneumonia and all 11 others are subcodes, so you can just traverse the graph? Or is it a bit more fuzzy? Because something you hadn't mentioned was using some sort of statistical methods to do the searching. So maybe you have like semantic embeddings, and then you know that maybe the cough code isn't related to pneumonia. It's not a subcode, but there's like semantic similarities, and you can like train a model. So is it all just through these graphs or that you're going? Can you be certain that there's a tree, or do you have to be able to expand your search to things that are maybe not in the tree?
That's a great question. And so it's not as simple. So the first part, it is fuzzy because some of the codes aren't. So like, for example, absence of something is often nested under the thing that it's an absence of. So like absence of cough might be nested under cough. So it's not necessarily enough to just say, oh, we want all of the child codes of this. There are also, it's not just like cough would have one layer of children codes underneath it. It would have like grandchildren and potentially great-grandchildren. And so you need to be able to get them all if they're relevant. And then there's a lot of effort manually put in at the moment to deciding what is relevant for a particular research paper. So, for example, if I'm doing a study where I'm looking at cough, and I'm actually, let's make it kind of more, say I'm looking at like pneumonia, or and I want to see like how quickly does it take from the first time you have a cough until you get diagnosed with pneumonia. Then it's not enough. I need to find everyone who's got a cough. But what I don't want is all of the people who are like allergic to their dog, or, you know, they have some other reason that they're coughing. And so that would definitely be under the header of cough, but it wouldn't be relevant to my study. And so, there's sort of, it's not as easy as that. To your semantic search thing, that's really what I'm trying to achieve with the next iteration, which will be the vector search side of trying to find these things by name. So what I'm imagining the builder is going to end up being is that you can say like pneumonia, find me all of the codes which are relevant to pneumonia, and then you overlay on top of that removing absence, and then also find me similar codes. And so that is something, again, which is manually done, which even if it's not perfect with the automatic solution, it will be a lot quicker than having someone sit down. I mean, I've spent hours and hours writing code lists. So, I don't want to do that anymore.
Fair enough.
Oh, and they also usually have to be signed off by 2 people at least. So it's a lot of person hours.
So also just having this as sort of a script that you can evaluate is much easier than looking at the full list. And
Exactly.
auditing it.
Exactly. So what happens at pneumonia? At the moment, I've got pneumonia on the brain now, but I am going to use the example of pneumonia. Say I wanted to do a study and I wanted to find all of the people who've got pneumonia. I might put in pneumonia, right? But I know that lots of doctors think that, and I think lots of patients actually, think that the word pneumonia is scary. So they'll say things like, you've got a chest infection, or you've got, whatever. And so you then need to also have that knowledge to be able to say, okay, I also need to find all of those codes which are lower respiratory tract infection. And so I have to have that knowledge, whereas I would suggest that if you did a vector search, pneumonia and lower respiratory tract infection will be pretty close together. Right. And so we can kind of use that. That's the plan.
You need to really be in touch with your user base and understand how people are describing things for you to be able to catch up on that.
Yeah.
Should we do a final question? Yeah, I don't know where the box is.
For 1 second. Yeah. You say vector search. Is this like a word embedding is what you mean? Something similar to that?
So I missed what the first part of the question was.
Sorry, you said vector search.
Yeah.
I assume you mean you're embedding words into some and then similar. Okay.
Yeah. That was the plan. Do we have any other questions? That was such short and sweet. So.
It was good. I would just like to say that I love that you're sort of bringing that open source mentality to science, like sort of a more open sciencey kind of thing, especially with the open code lists and publishing every part of the research is so important for making it replicable and that just so good.
Thanks so much.
Nice.
Shall I put this up? So
One last question. Yeah.
It's gone.
Where's the question?
So you mentioned that you're looking for some open source developers to help with this tool. Mm-hmm. More generally, are there any other places you recommend for either researchers who are looking for some developers who have some time to help, or people that want to do some useful development in their spare time to find tooling that's missing?
Oh, that's such a good question. We should invent that. I don't know specifically off the top of my head. I think if you did a search for open science tools, you could probably find something. But I would also encourage you to look at your colleagues or your personal background. A lot of us have come from science. So what were the specific problems that you were trying to solve back when you were a scientist that you could maybe bring some of your current knowledge? And it's really nice, actually, because you get to essentially kind of keep your hand in and have conversations with people that you really love working with. And hopefully you're doing something useful for them. And because it's open source, it doesn't have the pressure of my former academic life where it's I've got to get this out before this paper is due. I would encourage you to sort of just look around. And can we put the thing back on so I could just share the QR code for... I don't know how to do it, sorry. It looks really massive from here. Oh yeah, so if you scan this, it should have a bunch of links so you can learn about GitHub and then Women in Rust and some websites. Pardon? Really? Interesting. Okay, I will sort that out and maybe send it somehow.
Anyway, where they can find you?
You can find me through, I have a website, so carolinemorton.co.uk. You can find me on LinkedIn, and I can give you all of this information. We're always looking for speakers for Women in Rust. You do not need to be a woman. You can come and give a really good talk. And there's lots of people who are in the community who are really keen to help. Come and get involved.
All right, thank you so much.
Thank you.